Hello there, welcome to my class. I'm really excited and you should be excited too because this is your first chemistry class. In this lesson, we will be covering chapter 1, the particulate nature of matter. So chapter 1 only have 2 lessons, a really short and sweet chapter, very easy, so it should be a breeze. So chapter 1 talks about matter. What is matter? Matter is just any physical substance, something that has a mass, something that occupies space, something that you can weigh. So really chemistry is the study of matter, how they're like and how they behave and how they look like. And this is really unlike feelings or spirit or energy, things that you cannot touch or feel, cannot touch or weigh, but things that you just feel. So there are millions of matters around us. They all look different. The sea, the rivers, the trees, the rocks, the air. They all look different, but really they're all made up of really small pieces, very small for you to see. But for now, we're gonna call these tiny pieces particles. We're gonna get later into those particles, what they are. We're gonna talk more about atoms and molecules, but for now we're gonna call them particles. And everything around us is made of particles, even you and me. And so there are 3 states of matter: solid, liquid, and gas. And so there are many examples around us for solid, liquid, and gas. So for example, solids around us are like the furniture, the sofa, the chair, the food we eat, our books, our phones, the device you're watching from, the iPads. These are all solids. And examples of liquid are, for example, water, oil, juice, tea, coffee, anything that you can actually pour. And then gas is, for example, the air we breathe, or the air inside the hot air balloon, or air inside the ball, or a tire, exhaust from cars, motorcycles, factories, smoke. These are all gases. You'll notice that solids have a fixed shape and a fixed volume. You can, no matter where you place it, on a table or inside a cup, it has the same size, volume, and shape. But liquids, they do have a fixed volume, but they don't have a fixed shape. They just take the shape of its container. Gases have neither shape or volume. They just take up the whole space. And so, for example, this is water in solid state. We call it ice. We have it in our freezer. We have ice or snow when the temperatures really get very cold. This is water in liquid state, and we just call it water. We drink it every day. We have waters and rivers and sea. It's everywhere. 3/4 of Earth is actually made up of water, so it's everywhere. And then this is the water in gas state. We call it water vapor. We see it every day too. Vapor coming out of your cup of coffee or cup of tea, that's water vapor. That's in the gas state. Steam is also the really hot gas state of water that can be seen in an eruption of volcanoes or coming out of factory. This is water vapor. Just like water, almost everything else exists in solid, liquid, and gas, with just few exceptions. We will discuss about that in the next lesson, but everything else exists in solid, liquid, and gas. And so this is how we just learned how the 3 states of matter look from the outside, in ice form, in a water form, and in a gas form. But what about from the inside? From the inside, again, they are made of really small particles, really small that you cannot see, but actually very powerful microscopes can see those particles. And those particles, they move all the time. Even in solid states, they do move. We don't see it, but they do move all the time. And in the solid state, they kind of hardly move. They just vibrate, but they do. And then very closely, you will see that particles are arranged in a really special way in each state. So for example, in a solid state, the particles are tightly packed, regularly arranged. They want to move, but they can't because there's no space. So they just vibrate in their places. And there are really strong attractive forces between particles that hold them together. And then of course, because particles are so tightly packed, if you try to compress it, you're not going to be able to because they're already tightly packed. And so this is for the solids. For the liquid state, particles are not that tightly packed. They're close to each other, but they can move around each other, and they do move all the time. They can often collide with each other because they're still close to each other, and there are still forces of attraction between the particles in the liquid, but they're a little bit weaker than those in the solid. And similar to solids, you cannot compress liquid because, again, the particles are so close to each other. For gas, there is a complete disorder. Particles are just all over the place. They move freely and randomly, and they acquire the whole space. So just imagine the air around us. They just occupy. They're everywhere. Particles can sometimes collide when they meet each other, but not like in liquid because they're just further apart. And there's almost no forces of attraction between particles because, again, they're far apart. And because particles are far away, you can actually compress gas. You can make it come close to each other. And so, for example, you see those tanks, they contain compressed gas because we're able to compress it. And so when you see the particles, you can actually make gas occupy a really small space. But if you try to do that with, for example, a stack of wood, it's not going to happen because particles are already really close. You cannot compress it any further. I have attached a PDF file that really summarizes everything. I want you to study this table well. It compares solid, liquid, and gases in terms of shape, in terms of volume, in terms of arrangement, the attraction forces between the particles, the energy. So the particles in the solid state have very low kinetic energy. They cannot really move, they just vibrate. But in gas, they have a lot of energy. They move everywhere. And in regards to movement, again, for solid, they just vibrate. In gas, they randomly move. And I'll show you how to actually draw. It's really easy to draw the structure of solid, liquid, and gas. Now let's switch gears. I want to talk about the effect of heat on solid, liquids, and gases. So when solids are heated, particles, again, they're vibrating, but they vibrate more and more and more, and they push themselves apart. So solids can slightly increase in size. Same thing with liquid. When you heat it, they move faster and they increase in volume just a little bit. For gas, the volume increases immensely when you heat a gas. So when solids increase in size because of heat, we call this expansion. And when they're cooled, they shrink, and this is called contraction. And that's why when we build a train rail, they leave small gaps, because if you just build it with solid rain trail all over without any gaps, when summer comes and it's hotter, it's gonna expand and it's gonna buckle up and it's not gonna be smooth anymore. So we can't do that. We just have to really leave those gaps so that in hot days when it expands, there's this gap for it to expand into. Similarly with in roads, there are sometimes places in roads where it's made of metal, and those metals expand in the summer, and so we have to make sure there are those gaps just to account for this increase in volume and this expansion. And a really interesting example is telephone lines. They expand in hot days and they become a little bit relaxed, and then in the cold days they contract and become taut. And that's why we cannot stretch it all the way, because in the winter it's gonna be stretched even more and it might break. So next time when you go on a road trip, just look at those lines, and if it's summer, you should see that they're more relaxed, and if it's in the winter, it should be stretched out and really taut. On the other hand, for gases, the effective heat of gases is much more significant. The volume just increases so much. So remember, the smell of a barbecue travels much more further than, for example, the perfume you have on, because the barbecue is hot. So that makes the volume really larger. What I have just described so far is called the kinetic theory. So just basically, that's lesson one. That's what we described. This is a theory that scientists came up with, and they proposed three things. They first said, well, particles move all the time, and the higher the temperature, the faster they move. They also said that the heavier and bigger particles move slower than lighter ones. So if you're 10 kilograms or 20 kilograms heavier, are you going to run as fast? Are you going to move as fast? Are you going to climb the stairs as fast? I don't think so, because you're heavier, you're not going to be able to move. I remember when I gained weight, it was really hard to move. I felt really heavy and I didn't want to move much. And then the third thing they proposed is that matter's state can change by heating or cooling. So if you have a solid, if you apply a lot of heat, it's going to turn eventually into a liquid. And if you apply a lot of heat to liquid, it's going to eventually turn into a gas. And then the other way around is also true. So if you have a gas and you cool it off very, very cold, it's going to turn into a liquid. And if you cool the liquid, it's going to turn into solid. We're going to get into great details in regards to the change of states of matter in the next lesson. But this is it for the first lesson. You guys are all done. Make sure to study that table and make sure you take the quiz, which is really easy. Thank you. See you next time.